Determine the sum to n terms of the following series. Let us begin. So here we have a series whose first term is given by 1 multiplied to square of 2, added to 2 multiplied to square of 3, added to 3 times square of 4, and the rest of the terms going all the way up to n terms. Our goal will be to find the sum of this particular series. For this, we will have to find out the nth term of the series. So we will suppose that let Tn represent the nth term of the given series. Now, how do we find out the nth term of the series? So what we'll do, we'll look at the first digit of each of the terms. So here we have, from the first digit, we select 1. From the second term, we select the first digit, which is 2. From the third term, we select the first digit, that's 3. Now, clearly, these terms are going to be in arithmetic progression, and its first term and its nth term will be simply n. Next, coming to the second digit of each of the terms. So here we have 2 squared, we have 3 squared, 4 squared. Now these are not in these terms clearly are not in arithmetic progression. However, what we can do, we can drop the square. If we take 2, 3, 4 and the rest of the terms, they are going to be in arithmetic progression. And if they're in arithmetic progression, then the nth term is simply going to be n plus 1. So what we do to find out the nth term of the series, so first we consider the first digit of each of the terms. So that gave us the nth term is n. So we take n, multiply it to the nth term of the terms 2, 3, 4. So that's n plus 1. But we're going to square this value. And this is going to give us the nth term of the series. We can verify if this is correct or not. So if we choose n to be equals to 1, then t1, which will be the first term of the series, that is simply 1 multiplied to 1 plus 1 squared. So 1 plus 1 square means 2 squared. So we get the first term. Similarly, we can verify that with each of the remaining terms. Now let's now expand it. So this is going to give us n cube added to 2n squared plus n. So this is the expansion of n times n plus 1 whole squared. Now we'll try to find out the sum. Now the sum of the series 1 multiplied to 2 squared added to 2 multiplied to 3 squared added to 3 multiplied to 4 squared added to the remaining term, that this is going to be equals to summation. So we're going to write it in a compact form. It's simply taking the summation of the nth term of the series, and we are changing the index from n to k. Here the index k is going to run from 1 to n. In other words, we have to find out the summation of k cube. So here also we are going to replace n with k cube plus 2k squared added to k. So here k runs from 1 to n. Okay, so let's simplify the summation. So here we have summation of k cube. So k is going to go from 1 to n, added to 2 times summation k squared, where k goes from 1 to n, added to summation k with k going from 1 to n. Now let's find out the values. So what is summation of k cube? Summation of k cube, that is simply summation k cube. Now where k goes from 1 to n, this is simply the sum of the cubes of the first n natural numbers. So we have 1 cube plus 2 cube plus 3 cube all the way up to n cube. And this is given by n squared times n plus 1 whole squared divided by 4. Then summation of k squared, where k goes from 1 to n, this is going to be the sum of the squares of the first n natural number plus all the way up to n squared, and we have a standard formula for it, that's given by n multiplied to n plus 1 times 2n plus 1 whole divided by 6. And then finally we have summation of k running from 1 to n. This is simply the sum of the first n natural numbers, and we have a formula for this, that's n times n plus 1 divided by 2. Okay, so let's use all of this value. We have n squared multiplied to n plus 1 whole squared divided by 4, added to, now we have 2 multiplied to summation k squared. So 2 multiplied to this particular formula, the 6 in the denominator gets factored out, leaving us with 3. So we have n times n plus 1 multiplied to 2n plus 1 divided by 3. And then we have n times n plus 1 whole divided by 2. So we're going to combine this. I'm leaving the algebra part for you. That gives us the simplified form as, so this comes out to be equals to n times n plus 1 multiplied to n plus 2 times 3n plus 5 whole divided by 12. So this is going to be the sum of 1 multiplied to 2 squared added to 2 times 3 squared plus 3 times 4 squared all the way up to n number of terms.